So let's do one quick example just to play with this idea of orthogonal vectors. We want to find some non-zero vector v that's orthogonal to this other vector 1, negative 5. Okay, so let's say v has components v1, v2. Now we want it to be non-zero, and we want it to be orthogonal to this vector. So geometrically, that means its vector v will be perpendicular to vector 1, negative 5. Okay? Now, based on what we've just done, we know two vectors will be orthogonal if their dot products are 0. So what I want to take the dot product of this mystery vector v with components v1 and v2 with the vector 1, negative 5. So I'm just going to multiply corresponding components. So I get 1 times v1 plus negative 5 times v2. So plus negative 5 times v2 is negative 5v2. And I want to make sure that is equal to 0. So as long as I choose v1 and v2 so that I get 0 here, and so that v1 and v2 are not both 0, I will have my answer. Okay? Note that there are multiple possible options here. And let's just name a couple of them. One answer, just looking at it, I could see, well, if I make v1 5 and v2 1, then I'd have 5 minus 5 times 1. That'd be 0, right? Let me make that a little more explicit. Okay, that's one option. So I can make v1 equal to 5. I can make v2 equal to 1. That would be orthogonal to the original vector 1, negative 5. So here's another possible answer. Let's say we make v1 negative 10. Okay, then I could make v2 negative 2. And then I have negative 10 minus 5 times negative 2. That would also be 0. So negative 10, negative 2 would work also. Okay, another vector orthogonal to my original vector 1, negative 5. And if we sketch these out, and the problem doesn't ask for this, but we're going to do it anyway. If we sketch these out, we'll see that they are perpendicular to the original vector. So the original vector was 1, negative 5. I'm going to sketch that one out first. So 1, negative 5, 5. That's the original vector. Now our one answer here is 5, 1. So 1, 2, 3, 4, 5, 1. And you could see just eyeballing it that, yeah, that's going to be a 90-degree angle. That looks like a 90-degree angle, right? They are perpendicular. So these two orthogonal vectors geometrically are perpendicular to each other. Same thing for negative 10, negative 2. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10. Okay. Okay, and you could see, again, it looks orthogonal. In fact, any vector on this line that's parallel to that line will be orthogonal to the vector 1, negative 5. So if I take the dot product with this vector 1, negative 5, it will equal 0. So there's lots of possible answers to this problem.